Read chapter 4 of Bartle and Sherbert, a short chapter on limits. So of course, short in the Bartle and Sherbert is actually long by comparing to any other book, because, as I've mentioned before, the pages are tall. Now, all of this material is familiar to me by now. This is after I've read this concept in multiple books. It's a review, yet it's always a good idea for me to do that. I enjoy the repetition. So this is just your standard limits, theorems. Of course, they all recall back the same theorems in the sequences chapter, and so there's a little bit of matching one-to-one with some of the theorems. Of course, a very popular function is sine of 1 over x. You'll see it used very often to show that there's no limit as it gets to 0. Yeah. Of course, discontinuities, then limits that go to infinity, or also limits that are not infinite, but the function goes to infinity at that limit. Then I also started reading a little bit of chapter 5. I did not quite complete the first section on continuous functions. So as every other chapter on continuity goes, you start with point continuity, and then you graduate to uniform continuity. So that's the book, and then I'll briefly show my notes. Luckily, in the case of Bartle and Sherbert, there's always diagrams, and especially, as I mentioned, for this particular chapter, so far in what I have read, it's all very much material that I'm familiar with. Limits, theorems, adding, subtracting, multiplying, dividing, multiplying by a factor. So classic examples, and then of course Bartle and Sherbert, very sequential. We'll use the same examples for sequences, then they go and use them for limits, and then once you start reading in the continuity chapter, then they'll go back and also use those same examples for continuity. That's the end of my reading so far. Just beginning chapter 5. Got a little stuck on Thomae's function, which I've seen before, so I have to review this part where in Thomae's function, which is m over n, where m and n are natural numbers, equals 1 over n, and it maps this way. Now, I get the part about the rationals being discontinuous at the rationals, but it's continuous at the irrationals. I gotta revisit this because I'm just not getting it right now. I mean, all I see is rationals. So this is one of those where I'll have to do some reading and maybe even invoke ChatGPT, hopefully not to give me the wrong answer.